Welcome to yet another motorized project I've been working on. This one is a motorized bicycle. I've been wanting to build one of these for a while. So I bought the engine kit, including the engine, tank, sprocket, chain, and pretty much everything you need. Everything except the bicycle for 140 bucks. And you can get those online in lots of different places. So it's 66 cubic centimeters, and I guess it puts out about 2 horsepower. But there are some common issues that these things have that you have to deal with that makes it a project, and it's part of the reason it's so cheap. But I wanted to build this on a cruiser bike, and I ran across one recently and bought it for $10. This is a Murray Westport, made in the 70s approximately. They made these from the late 60s through the very early 80s, 81 or so I believe. And so this one is somewhere in that time range. And like I said, I got it for 10 bucks, which was a bargain. It was actually rideable, somewhat anyway. It had a flat tire with a big slash in or big split in the rear tube, so that had to be fixed before it could be ridden. But on to the motorized kit. Like I said, these have a few common issues that have to be dealt with. And the first one is the drive assembly. And I did have several issues with this actually. You might notice that I've written on it. Those are tooth counts. And that's because I had to find the center of it, and I put it in my mini mill with my rotary table, and machined out the center hole because it was too small and wasn't working on the hub. Of course, you can do that with a $10 die grinder, assuming you have an air compressor that'll drive it, or you can do it with a Dremel. It's slow, but it can be done that way if you need to open yours up. Or you can even use a file. You know, there are any number of ways to do it, but since I have a mini mill and a rotary table, and I had never even used the rotary table, I decided that that was the way to do it. So that out of the way, then I had problems with the chain slipping off. And part of it is that it's difficult to get this sprocket properly adjusted. It's not really that difficult, it's just tedious, because it's got a rag joint in there that sandwiches the spokes, and then it's almost impossible to get it perfect, so you've got to run this chain tensioner, and some people don't. I don't know how they get away without it. I've tried it and it didn't work. So anyway, I had issues with the chain coming off, and at one point I had the tensioner mounted back here, and it actually, when I tried to start it, it sucked the tensioner down into the spokes and destroyed the rear wheel, which was a pretty lightweight wheel anyway. It had 14 gauge spokes, and it was always my intention to switch to 12 gauge spokes. So what I did was bought a complete new wheel with 12 gauge spokes, and I got it for approximately the price of just the spokes alone. So I was able to retain the rear coaster brake, which I wanted to do. Now the other problem was mounting to the frame so that it wouldn't rock, and I did some modifying on the front engine mount, and then I stuffed some JB Weld in there to fill the gaps so that it would set straight. So I finally actually got this thing going so I could ride it, and I've ridden it a bit, probably a couple of miles. But let's see, front end, let's cover that. I was given an old mountain bike, not all that old, not nearly as old as this bicycle, but several years old nonetheless. And it was an aluminum frame, which I have no use for. But it had this suspension fork on the front end, which I normally also have no use for, but I decided for the motorized bike that might be a good thing to have. So the main thing is that it gives me front brakes, which cruiser bikes normally don't have, but with a motor capable of moving you 30 miles per hour plus, you really need a front brake. And this suspension fork had the 1 1/8 inch steer tube, which was not compatible with this frame. However, being an aluminum frame, it had pressed in bearing cups, the donor bicycle did. And happily, I found that this one did too. It wouldn't have been a huge deal because I could have cut the caps off if they hadn't been pressed in, but it turns out that they were pressed in, so I just knocked the bearing caps off the aluminum frame, retrofitted them onto this, and that allowed me to put that fork in place. And I used the handlebar and everything, the entire front end from the aluminum bike, wheel and all, tire even. Used the whole setup on this bike. So it rides pretty well and has good brakes now. Okay, now the third issue that I've read about is most of these engines that I've read about have a third wire. This one only has two. And that's just, one of them is grounded. The black one is grounded, as you can see there. And the blue one is the other end of the coil. And most of them have a third wire, which is for a 6-volt output for lights. But I've read of people having problems with that, where they turn the lights on and the motor wants to cut out because it's stealing power from the ignition. And apparently there's not a lot of excess power for the ignition, which is why that's a problem. Well, this one doesn't even have the third wire, and that's probably why they eliminated it. But just a second, let me grab something. Okay, we're back. I got to thinking, you know, it would really be nice to have a lighting output, lighting / battery charging. And I would really like to have 12 volts instead of 6 volts. And so I can charge a little 12 volt sealed electrolyte battery and use it to power a small radio, ham radio that is, in addition to lighting. And I only need a few watts, maybe 3 watts. 3 to 5 watts will be sufficient. So I looked at the core here, and I could wrap some wire around the outside of this and tap off of that, but that would still affect the ignition winding a little bit. But there's an empty spot right here where there's nothing, and there's a magnet in here, and what it does is it magnetizes this core as it passes it, which creates a pulse in the winding here to produce a electric pulse to drive the ignition. And by the way, an issue that I've heard reported is they say you've got to seal this little cap really well, because if you go through a mud puddle and get water in it, it'll burn up this coil. Well, I don't believe it. I don't see how that can possibly happen, because I measured this with my multimeter, and it's 325 ohms, which means there's a lot of windings of small gauge wire here, but there are no diodes or anything in there. So all it is wire, and so there's no way that a little bit of water can burn that up. Now what it might do is it might temporarily short it out and make it not run until it dries, or it might even, if you get one that's a cold solder joint here or here, water getting in there could create corrosion and kill your connection. So that could happen, but it's not going to burn the coil up. I mean, keep in mind that it's got a kill switch, and the way the kill switch works is by grounding this blue wire. So, you know, if grounding the blue wire is not going to burn up the coil, neither is getting water on it. Nevertheless, it's probably best not to get water on it, but I just wanted to cover that. So anyway, this magnet swings around, creates a pulse, but when it's passing this empty spot, it's doing nothing. So what I did was I had some steel strapping material, and I cut 12 2-inch pieces and welded them together at the ends and on the back. And so my plan is to wrap enough wire around that to generate about 12 volts. Or, you know, if I can only get 7 or 8 volts, or even 5 or 6 volts, that'll be fine. But you know, if I'm limited in space, which I doubt, I should be able to get 12 volts. But anyway, my plan is to weld some tabs on this and make it so I can set it right in there and wind wire around it, and I'll probably drill another hole in this cover instead of in the actual engine case itself, and bring the wires out, and or maybe probably just bring one wire out. I don't know. I might just ground one side and bring the other side out. But anyway, whatever. I plan to create my own electrical outlet, and it shouldn't mess with the ignition at all, since it's going to be completely separate. And it also shouldn't pull the engine down much, because even if it consumes, say, 7.5 watts, that is, if this thing produces 2 horsepower, a horsepower is 720 watts, or 746 watts. So therefore, if this consumes 7.5 watts, then that's only about 0.5% of the output of the engine. So I shouldn't be able to tell any difference at all from that, while having enough electrical output to run what I need to run. But I'm not going to do that right now, because I've got to take this out there and ride it some more to break it in, because the instructions clearly state that you should run a 16:1 oil mixture in this for the first gallon. And since it's supposed to get about 100 miles per gallon, man, that's going to be a lot of riding. So I just want to do that before I tear into it any further. So I'm going to put the cover back on it and ride it some more. So be watching for updates.